Hello everyone, my name is Abhishek Singh and in today's video I am going to talk about a very interesting topic that is important for JEE Mains Advanced as well as the NEET student. That is, and it's a very interesting topic. We are going to use several concepts work energy, regarding work energy theorem, energy conservation, and some type of FBD problems, and all whatever we have learned in Newton's law of motion and in circular motion and in work energy theorem, we all use in this particular concept. So if you study this concept very well, all your previous concept will also be revised. And in this concept, just a lot of things can be made. So you have to know this concept in a very well manner so that you can make the question whatever it is framed by your examiner or by your question paper maker. So let's start the topic. We are not going to delay any soon. So let us start the topic. What is that? Like vertical circular motion, how it is happening in vertical circular motion. Let's see. What is this is the exact image of the vertical circular motion. I have copied this image from a source of internet to make you understand, because I am not a guy who can draw a complete circle. So I have copied this. Let's see how. Like this is u. This is the lowest most point of the vertical circular motion. This is lowest. We have given some velocity. Okay, we have given some velocity so that it completes this circle. So we do analysis, like whatever the velocity is given at this point, what is happening at this point. Let's suppose this point is A, we have given the name, this is B, and this is C. So we have given the name, remember this name, A, B, C. So we do the analysis according to that. Like if we give velocity is equal to something, what is happening at B, what is happening at C, how the tension is varying, how the velocity is changing. We do all type of analysis. That is called vertical circular motion. If we given the velocity is this, what is at B, what is between A to B, what is between B to C, how the tension is varying, how the velocity is varying. Velocity can be zero, tension can't be zero. So many questions can be made. If you know the concept very well, you can able to answer all those questions. So don't try to learn anything, just try to don't try to remember anything, just try to learn and understand all the things. Don't try to remember. So now we are going to start. What is going to we see the first concept, that is minimum velocity should be given at lowest point so that it completes the circle. Now we see what is that u minimum. We are whatever we are going, that is we are going to calculate what minimum velocity we will give to this ball at lowest position so that it completes the circle. So now consider, we assume this length is r. You can suppose anything, you can suppose it L or something, but I have supposed the length is r. So let's see what are the things that is happening. First of all, draw the FBD at lowest most points. How it is big, as I shown here, that is tension T1, that is mg at A. I am drawing FBD at A. After drawing FBD, we do different analysis. First of all, draw FBD, and this is centripetal force towards the center. We know because that is moving in the circular part, so that will must be applied. Then this equation according to T1 minus mg, that is equal to mv square upon r, and this mv is the v minimum because that velocity has given at point A. So the FBD at A includes the v minimum. T1 minus mg is equal to mv square upon r. So let's see a lot of things. How will you calculate? Like u minimum, that should be given. So do the analysis. Like the ball is moving like this, the ball will go to B and then go to C. So one thing you can notice, if the ball covers the point C, once like we have given amount of that much velocity so that it covers the point C, and once it covers the point C with having some velocity, it covers the point C, automatically it completes the circle, because there is nothing to do with this, because it automatically happened. Automatically gravity has come into the play and it will show its effect. So we have only to do just to reach at the point C, and once we once we force the ball to reach at the point C, automatically it completes the full circle. And it completed the circle. Why it completed the circle? Because the gravity come into the play, so that it completed the circle. So now see, you have understood the object should have some velocity at C. So now it should have velocities at some C. So see the condition of C. At C, what is happening? At C, the ball is this direction is T3 plus mg, and this is equal to mvc square upon r. That is T3 plus mg is equal to mv square upon r. Now what we need to do? We need to minimize. What we need to minimize? We need to minimize this velocity, because we have to calculate minimum velocity. So whatever the minimum velocity is here at C, accordingly we get the minimum velocity at A. So we have to minimize this. So just see this equation. Automatically, if you see the equation, you will know that how will you minimize. Just see the equation. If we make tension 0, then automatically it will become a minimum, because we are going to add something now. And if the adding value is 0, then automatically we have added null, and once we added null, it means it is the minimum condition. So we have made the tension 0. So for minimum velocity, we have made T3 0 for minimum velocity, because we have seen according to maths. Because when we make T3 0, then accordingly we get the minimum velocity. So what minimum velocity we got at C? It should be, that is root gr. So our first work has completed in solving this problem, that we have got the minimum velocity that can be possible at C. And once I have already told, if there is any velocity at C, then automatically it completed the circle. Because gravity come into play, automatically you will think that if it crosses this point C, then automatically it complete the circle. So first part we have done. Now let's see the second part. So from previous part, what we have calculated, that VC, minimum velocity at VC, is under root gr. Now the point is that what we have given the minimum velocity at u minimum. So nothing is more serious with this. We have got VC, that is root gr. So we have to just using work energy theorem. You can use an energy conservation also. I am using work energy theorem. What is work energy theorem? Work done by all forces is equal to kinetic energy final minus kinetic energy initial. That is work done by all forces. Now see which forces are acting. Tension work done is 0. Already perpendicular to velocity. So tension work done is 0. In circular part tension work done is always 0. So only gravity. So gravity is there. mg. What is work? You know that work. What is the formula of work? F dot ds integration is known as work. And once F is become constant, then it become F into ds integration, and ds integration become displacement. So force into displacement. After 3 steps, after say certain condition, that become the force into displacement. The main formula is F dot ds integration work. So we will do work. Since mg is constant, so we can apply this part. Since mg is constant, so we can apply. If mg is not constant, we are not going to apply F dot ds. Understood? If maybe the question paper make sure that you please take, like here mg is constant, because in question nothing has said about the mg. That question has nothing said about mg. It means mg, because we suppose in maximum of the question that mg is constant, but examiner can examiner can make mg variable. He has said please consider mg is a variable force. Mg is variable force from it gives some certain function like k into x. Mg is variable with k into x. So in that condition, you are not going to apply f dot dx directly. So always always open your mind, always open your eye, ear, nose, tongue, skin, whatever you have. So always always think what the question is given. Here nothing is said about mg, so here mg, so gravity is constant. But question paper maker can say please consider gravity to be variable with x, with distance. So in that case you have to use f dot dx. You have to integrate with force variable quantity with displacement. so that you get proper work in that case. But here nothing is said, so we are considering the ideal case. Mg into, and upper distance is what? That is minus 2r, because force and displacement have angle and 180 degrees, so minus. And kinetic energy final, that is 1 by 2 m into that Vc square, minus 1 by 2 m or a initial square, and whatever the u minimum square. So we have calculated this, and from here we get u minimum is equal to under root 5 gr. So now we have got whatever the minimum velocity that should be given at lowest most point to complete that circle. So this is the minimum velocity. So sometimes it is also called as critical velocity. Many people call it as critical velocity also. So don't feel like you don't know what is critical velocity. So this is many books saying that this is critical velocity also. So basically the concept is that this is the minimum velocity that should be given at lowest most point, so that it just completed the circle. So till here I think that you have understood, and I have just explained the concept, very important concept of variable gravity, variable force, or something. In that case you have to change only that you don't have to apply directly force into displacement. You have to go with the formula, basic formula. You have to know that is F dot ds. At that time you have to do F ds and then do the integration and find the work. And after finding work you do kinetic energy final minus kinetic energy. So nothing is taken with that. So if the examiner make the mg variable, then also you can able to solve, because you just have to change the f dot dx. So now I think you have understood. So just move ahead. What are the further things that we are going to discuss? Since I have said this is a very diverse topic, lot of things you can make. So in that case, let's move further. So now you have seen what we are going to discuss, all calculation using critical. Once we have calculated critical velocity, that critical velocity is what? Under root 5 gr. Then what are the certain conditions that is happening once we given the velocity u minimum under root 5 gr at lowest most points? Then what are the other what are the velocity at other point and other other places? Like this is the lowest most point, this is this point, and this is we do analysis at this point. I already named that is A, B, and C, and this is the part of your circle. Okay, so we do analysis. So first we will find that is TA. What is TA? And we are able to know that is u minimum, and we also find acceleration at A, that is TA as well as acceleration at A. Just make the equation at TA. So at A what is happening? TA minus mg is equal to m u minimum square upon r. This much by using the using the everyday tension minus mg, because tension is upper, mg is downward direction. So this equation we got. So for finding tension, what will you do? That is minus mg, and we put this value, that is mg 5. U minimum that is under root 5 gr. So we put this value here. So we get TA is equal to 6 mg. So TA we have got, TA is equal to 6 mg. Here we also find what is acceleration. Acceleration is nothing new. Acceleration is only that is centripetal acceleration, that is v square upon r. And what is v square upon r? That is 5gr upon r. It means that acceleration is only 5c. So we have calculated what is the A acceleration at lowest point, what is the tension at lowest most point. They can be questioned, this type of questions can be also asked, that if given velocity is critical velocity, then what is acceleration at A, what is tension at A. And now we will see at B. So we will see in next slide what is what is happening at B. This is the B point. So here that is TB, FBD we are making, that is gravity, and in this direction no force is there. Then TV is equal to mPV square upon R. So for finding TB, what we need? For finding TB we need VB, means we need velocity at B, and we don't know velocity at B, but we know the velocity at A because we are finding the condition of u minimum, that is under root 5 gr. So we know the velocity at B, we know the force, we know the work, we know the distance, and once you know everything, so we use work energy theorem, that is m minus mg into r. Final kinetic energy 1 by 2. I am not writing everything, you know the work energy theorem. So 1 by 2 m Vv square minus 1 by 2 m u minimum square. So from here u minimum we get what we get, u minimum to we know, from here Vv we get under root 3 gr. So we have got what we have got under root 3 gr. So once we get the Vv, then we will get Tb, m into 3 gr upon r, that become cancelled, then Tv means tension at B is equal to 3 mg. We have calculated in that part tension as well as acceleration at point A. Now we have calculated the tension and we have calculated tension at B. Now we have to calculate the acceleration at B. So C, what is tension at B? That is 3 mg. So acceleration C, there is two acceleration, that in two direction. One direction is tangential, this is radial. So tangential, what is tangential acceleration here? That tangential acceleration is gravity only. Means tangential acceleration is equal to g. And what is radial acceleration? That is v square upon r. And what is v? That is 3 gr upon r. It means the radial acceleration is what? AR. AR is equal to 3g. So maybe anyone can ask what is radial and what is tangential acceleration at B. So AR, we have got AR is equal to 3g. We have got AT is equal to g. So for total acceleration, we know we have to square, because these two are vector and then both have angle 90 degree. So we use the formula of vector. Then this become root 10 g. So acceleration at B is equal to under root 10 g. So this also you know. Now we have to all the analysis whatever required in the condition at A and at B. So I am just I am doing everything in a very proper manner. I am deriving all the things so that you get the concept. You have not to remember what is tension at B. We have not to remember what is tension at what is tension, what is acceleration at B, what is tension at A. You have not to remember. You only know how am I finding. I am only trying to explain that how am I finding. I have not remember anything. I have studied so much time before ago, but still I am able to recall all the things because I know the way how to derive. And once you know the way how to derive, and in competitive exams like JEE or in competitive exams like JEE, they want you to how to approach. They don't want to make you remember everything, because for if you want to remember everything, just give the exam of board, because at that place remember is important. But here it is not about the important. This is competitive exam, how you approach, how you know the question. So for approaching, you know how the things are coming. So I am just trying to make you learn that how I am just trying to make you learn how to know, how to derive, how to know the things. So as whatever the way I have remembered, I am just explaining my ways so that it will be beneficial, and I think it will be beneficial for you to all. That's why I'm doing this. Otherwise, I will not do if it is not beneficial for you all. So now we have calculated everything regarding that is under root 5 GRU minimum. We have done all the calculation regarding that velocity. So now we are going to see one new part, that is analysis of vertical circular motion at different points. So we have calculated this point, this point. We have find everything whatever at A and at B, that is acceleration as well as tension. We have find at A and at B, and already see you already know everything. So we have find all the point whatever. So we have find in what condition? We have find in that condition when a velocity at A is under root 5 gr. And I think you know the approach. When velocity is under root 5 gr, we have calculated the thing when velocity will be somehow less, somehow 5 by 2, somehow 10, somehow more than. So you are able to calculate that also, unless and until if there is not problem. Maybe the slacking of tension and something, maybe extra thing happen, but you know the way how to approach. What will the velocity? I've explained you working how to apply work energy theorem and how to apply FPT and how to how to apply circular motion for finding acceleration and tension at AB. Now we are going to analysis between A to B. In multiple choice questions they might ask these type of things also, because they might ask what is happening between A and B, what is the value of tension at A and B. So for that type of generalized question, what we are going to take a generalized point. Usually do for finding we need to take a generalized point, so let a point at alpha. So we are making here mg, this is alpha. From alternate angle this is also alpha, and this is what in the direction of alpha, that is mg cos alpha, and in perpendicular direction that is mg sin alpha. And here tension, I think you know the way to FBD, and in this direction that is your centripetal acceleration v square upon r at this point at a certain angle v alpha, that is v alpha square upon r at velocity. So what is equation of motion? That is mt minus mg cos alpha is equal to mv square upon r at this point. So this is in direction. Understood? So now we have written the equation t minus mg cos alpha is equal to mv square upon r. We have written this equation, and once we have written the equation, we are trying to understand this equation. Let's see what are the things we can say by just by seeing this equation. We are able to say a lot of things. What are things? Like, just see what happened when tension becomes zero in this equation. See, when I'm not going to write, just see when tension becomes zero, what happened? Let's suppose that tension becomes zero. When tension becomes zero, what happened? That mg, this become minus mg cos alpha, and this become mv square upon. Oh, here square, here minus. Oh, wow. V become infinite or undefined, means there is nothing v with this, because there is no any value of v or anything condition between a to b. We are doing the analysis between a to b. This is between a to b, because in this partner we have made whatever, this is b, so we have made the ability between a to b. So we are doing the analysis between a to b. At b to c means at here something will be changed, because the direction of forces become changed. So in next slide we will do from b to c, but now we are doing from a to b. So from a to b, when condition is from a to b, what are the certain things by we can say by seeing this equation? Tension can't be zero. Tension can't be zero, because once we have seen, if we make tension zero, then v become infinite. So tension can't be zero, velocity can be zero. So these two things can be said. This type of question may be asked in the multiple choices, that tension can't be zero in, like they suppose, is it true that tension can't be zero? What is happening with velocity between a to b? So this type of analysis we do between a to b. So now I think you have understood. Just we need to write the equation, and once we write the equation, we are able to see everything. So just go to further. What is happening between from b to c? From b to c, suppose this is b and this is c. Let's suppose here this angle mg, this is mg, and this is here alpha, and this is mg cos alpha, this is mg sin alpha. Okay, and now in this direction tension, that is unlikely in from a to b, because in that part tension minus mg sin alpha is there, but in here tension plus mg sin alpha is equal to mv square upon r. So here analysis gets changed, because in this part there is nothing minus term, so in this part tension can be zero with so much ease. Tension can be zero, so much ease, tension can be zero. But in this part, what is not true? That velocity can't be zero. Velocity can't be zero. So don't be confused. See the equation, that if you do zero, what is happening? Like velocity, if you make this part zero, what will happen? This become tension minus mg sin alpha. It can't be possible. So velocity can't be zero. If some type of question is asking multiple choice question or any, just don't remember the thing. Just write the equation from that part. write the equation in that part. We have to just know the thing, write the equation in that part, check the equation, do the analysis. I have written the equation, check the equation, do the analysis. Analysis will be done automatically, you have not to remember a single bit of this. So everything done accordingly your mind. So you have to write only the equation. Any type of question is going to ask, just do the same thing whatever I have done now. So I think you have understood how to do analysis and how to solve multiple correct multiple choice question. So understood. Now this question can be asked in single correct also. So single correct peoples don't don't remove this question. Always take care of this type of concepts in your mind. So let's move further. What are the further thing? Now velocity is equal to root 4 g. This is the most interesting part of this video. Like what is going to happen when velocity is under root 4 g. Like you you have got something like when velocity is equal to under root 5 gr. By the way, when velocity is under root 4 gr, it means minimum velocity at lowest point. What happen when velocity is equal to under root 4 gr? What are the certain things that are going to happen? So this is the most important case, because I am going to do lot of analysis here, and you are going to learn so much good things in this part. So please see it till end. So when you become under root 4 gr, then it completes the circle. It completes the circle. What velocity that should be given to just reach at this point? I have calculated that. I think I have not calculated that. So just to reach at this point, it means at this point the velocity is what? Velocity is nearly 0, because we have just to reach that point. So what will be happen? The final kinetic energy become 0. Initial kinetic is 1 by 2 u square, and that is equal to mgr, and this u minimum is equal to under root 2 gr. So from here we can say that if we give velocity u minimum, if u minimum is equal to under root 2 gr, then it just reach to c. Means if we give velocity is equal to under root 5 gr, if u is equal to under root 5 gr, it completed the whole circle. And if velocity is equal to under root 2 gr, then it just reach here when velocity is equal to under root 2 gr. So what happen when velocity is equal to greater than under root 2 gr and less than under root 5 gr? It means neither it will complete the whole circle, nor it is coming down from this point. It means it crosses this point B. It crosses the point B but not crosses the C. It is something between B to C. It get collapse. It get fuss. It get it get confused between B to C. Just it get stop or whatever. I mean it has crossed B but it has not crossed C. So what happened to the ball? It has crossed B but not crossed C. What happened to the ball? Let's see what happened to the ball and what are going to do, because that's why I have made the thing interesting now. I've seen that when u is equal to under root 4 gr, you have under root 5 gr, and that where I have considered the under root 4 gr. Just see 4 gr. 4 gr is in this range, whatever the range I have explained, that under root 4 gr is in this range. So let's do the analysis. A very great, good analysis. So now you have understood that ball become ball crosses this point but not crosses this point. It means balls is something between B to C. So what happened at the ball? Let's see. In this part I have explained that velocity can't be 0 in this part, because once velocity become 0, then tension, velocity becomes 0, then tension become your tension become negative, and that impossible. So in this part tension can be 0 but velocity can't be 0. So what happened? For a certain value of velocity, tension has converted into 0, and once tension has converted into 0, it will leave the vertical circular motion. So considered, it will leave the vertical circular motion. So now ball will, what happen? Ball will leave the VCM, that is vertical circular motion. Ball will leave, ball will give dagabaji and dhokha or something like in Hindi we say. So ball will leave the vertical circular motion. So now the one question has made, what, at which point, like which point, ball will leave VCM, let's suppose at which point ball will leave VCM. Suppose here. So now we don't know the point, so we will try to calculate which point will leave the VCM. And also this is one part of question, and which point will leave the VCM, as well as calculate maximum height from the ground, which means from lowest point, calculate max height. So now a very good question has created, calculate maximum height. First find which point it will leave the VCM, and then find maximum height, because once you are able to find it become projectile, and after that you will the maximum height formula and calculate. So long calculation is going to meet, so just see how to approach. Now suppose that, like here we are making the diagram, like this is ball, this is something, this we know that it has crosses this. Let's suppose it has leave the surface at some angle alpha. So what are the things that are happening at angle alpha? This is tension, and this is 90 minus alpha, and this is angle alpha, this angle alpha, and this is mg, and mg cos alpha is there, nothing lena dena with this, and this is mg sin alpha. So what will become tension plus mg sin alpha and is equal to mv square upon r. We already said tension will become 0, so that it will leave the surface, and velocity is equal to under root rg sin alpha. We have got the velocity and alpha in one term. We will use this. We are going to use this. So we have got velocity is equal to under root rg sin alpha. Means when it will leave the surface, at that time velocity is equal to under root rg sin alpha. Now we have got v and alpha relation. Once we have got the v and alpha relation, if we get one more equation in form of v and alpha, then it become two equation, two variable, and we will solve. So let's try to get one more equation. And from where we get the more equation? We get one more equation from work energy theorem. So just a fresh page, we are going to work energy theorem, and this is alpha where it leaves the surface, and this is already said mg, this is mg sin alpha, you already got, this is mg sin alpha. Now we have got the relation between v and that is rg sin alpha, v and alpha. Now we are trying to find one more relation between v and alpha, so for that we are going to use work energy theorem. So this is r, and what is the length of this? This become r, what, sin alpha is equal to p by sin alpha is equal to, that is perpendicular by hypotenuse, that is r sin alpha. Understood? You have this got the length. So work done by all forces, that is mg, and this is r plus r sin alpha, because that is r and this is plus r sin alpha. Final kinetic energy 1 by 2 m, that is v square, minus 1 by 2 m, and u that we have given, what we have given, that is 4gr. We have given 4gr na, that's why we have calculated all the things under 4gr na, right from in the starting we have given. Now we are using v square, so we will put the value of v square from here, that is rg sin alpha. We will put the value of v square from here, and we will try to solve. That become mgr minus mgr sin alpha, and that become 1 by 2 m rg sin alpha, and that become minus 1 by 2 m to 4gr, that become 2, and this 2 will come here, that become mgr, and that become, it will come, that is 3 by 2 mgr sin alpha, and then become sin alpha is equal to 2 by 3. So we have got the condition. Now we have got this at sin alpha is equal to 2 by 3. It means alpha is equal to sine inverse 2 by 3. It will leave the surface. It will leave the surface. Now you have understood it will leave the surface at alpha is equal to sine inverse 2 by 3. At sine inverse 2 by 3, it will leave the surface. So now we got that it will leave the surface when alpha is equal to sine inverse 2 by 3. Understood? So now we have got the first part of question, that at alpha is equal to sine inverse, and that is sine inverse 2 by 3, it will leave the surface. So now we are going to calculate what is the maximum height, man. So for calculating maximum height, let's see, we have to see some situation. Like this is R, this is R, this is alpha, this is R sine alpha. So first of all, this height is R and R sine alpha. Two height we have got, that is R plus R sine alpha. Now after removing from here, it will become a projectile motion. So it has, let's see how it becomes projectile motion. It has converted into this projectile motion, and nothing is that this will be alpha and this will be 90 minus alpha. So we have to calculate what is the velocity of the projectile motion. What is, already we have to find, that is rg. What is velocity at that point? That will be the velocity of the projectile motion, because velocity is not going to change now at 2 by 3. So velocity at this point is, indirectly it means velocity of the projectile motion is v by 3 root rg. Okay, now for maximum height, what is the formula? According to projectile, that u square sine square theta upon 2g. But here theta is not there. What is 90 minus alpha? So it will become u square cos square alpha upon 2g. And what is u square? U square is 2 by 3 rg. This is 2g. This is cos square alpha. What is sine alpha? Sine alpha is there 2 by 3. What is cos alpha? 1 minus 4 by 9. 5 by 9. Cos square alpha is 5 by 9. So g से g cancel, 2 से 2 cancel. What become? That is 5 by 9. That 5 r by 27. And here sin alpha, that is 2 by 3. It means r plus 2 by 3 r plus 5 r by 27. This is 9, means 18, 27. This is 27. This become 50 r upon 27. So that is the maximum height. So in this question we have used everything. We have used projectile, we have used factor of tension become 0, and it will at what distance it will remove the surface. So at that also we have used work energy theorem, we have used FBT, we have used circular motion, we have used projectile. So in this question we have used everything. Understood? We have used everything. Now I think you have got everything related to this kind of thing. So just in this full video I have explained lot more things regarding the whatever the vertical circular motion we are going to study, and how we approach the question, like in which manner we are going to solve. I have not said you to remember anything, just go with the approach, because many type of questions have been created by the question paper. So go with the approach. So just I will end this video. If you want me to make some more videos, so please like and subscribe, and have a good day. Thank you.